All right, any disagreement with what Rosie said? Any disagreement with Rosie's answer? Do you like it? Yes.
I love your graph, Rosie. What do you want to label?
We should make it clear what the scale is, or if you want to label points, that's fine too if it's not clear. But I think this is -1 and this is -2. Am I right? Okay. So, yeah, we could make that a little clearer maybe, but somehow make that clear. And then, so is this 1.5? Is that what I'm to understand? Okay. Yeah. Do you have anything else to say about the warm-up? Anything else to say about the warm-up? Okay, good. All right, we want to just keep talking about this section. Here's everything. Look. Do you remember all this stuff? Yes? Yesterday was awesome, right? Yeah. Okay. So we only threw two different transformations at you at once yesterday in class, and in the homework too. So things were not too bad. But I know you're used to. I know that you've experienced some of this before, and I think we're ready to jump to 3 or 4 different things happening at once. Before we do that, we want to outline maybe what our thought process is in attacking one of these harder ones. You might think this is overkill for the kinds we've done yesterday and last night's homework, but I think this is a helpful kind of framework to lay on top of this process. And I have stolen this slide wholesale from Ms. Getz's PowerPoint from last year, so this might sound familiar, okay? The roadmap to success. I thought it was good. Why reinvent the wheel or the circle or whatever? Okay. So the first thing you might do is, and we've already been doing this, right, is identify where the sinusoidal axis is. Maybe plot that if you like. I mean, I'm not a believer about that necessarily, but it might help you, right, to gauge where the middle of your road is if you're thinking about a road analogy. And then, how wide is the road? Well, what thing tells you that? The amplitude, so go above your road by an amount A and below your middle of the road by an amount A. And then the next thing you might think about is where's the beginning of the road? And for that we might need to consider something we haven't considered yesterday yet, and that's the phase shift. Remember, H is our letter that we assign to that value. Where is the end of the road? Where does the end of the road come? Well, if you already know where the beginning of the road is it H? Where is the end of the road? H plus the period, or 2 pi over b if we're working in radians, right? And where are the road marks? And by road marks I mean the other things we have interest in. The other places we might have interest in are where any maxes or mins occur, and also where any places where we have it cross the sinusoidal axis or come back to equilibrium, right? So that's a total of 5 points total, then 2 on the end and then 3 in the middle. So how often do those occur? We we can plug in values, but we can also use an argument from symmetry and just divide up into how many pieces.
It has an extra way just of one of the sides.
Not necessarily. No, you're right. It's not always convenient. Yeah. Green.
In the homework, or in the future, do we always have to define the x intercepts for one thing?
Is that something they made you do or something? They asked you to.
It's in the homework. Sometimes I couldn't find the exact numbers, so I just eyeballed it.
I don't see the problem. They want you to graph it. Is that what you're asking? They're asking you to graph something.
Yeah.
And the question is, and they want you to graph a certain number of periods or something?
Do you need to know exactly where the graph touches the x-axis?
I mean, sometimes that's impossible to know without a calculator. Sometimes it hits in a weird place. So no. The places maybe that are more of an interest to you and me are the places where it hits the sinusoidal axis, wherever that is, right? Yeah. Yeah, they might not be convenient values, or it might not hit the x-axis at all, right? Where it hits the x-axis. It should be clear from your picture, and if it's not, then label it, right? But if you have it really well labeled along the axes, then that's fine. Yeah, I can look at it. I mean, whenever you make the graph, it should be clear where the maxes and mins are and where the places where it would intersect the sinusoidal axis are, I think. All right, let's graph one here. This one finally has a couple more interesting things happening.
Eric, it looks like you have a wig.
Hey guys. Thanks. All right. So I'm going to try and follow those steps in the order I just talked about. I think the order in which I presented them is a good order. So if you guys would be quiet, that would be great. Okay. So y equals 1 is the sinusoidal axis. So I'm going to plot that first, right? And again, you don't have to plot it, but I think it helps us. I think it helps us like formulate where the road will be, and we go up 2 and down 2. That's the amplitude, right? All right, and then if we plug in 0, there's no phase shift. You see that? So plugging in 0, that's going to be kind of our starting position here for our road. Right here at x equals 0. And actually, we can just plug it in if we like, or we can think about transformations. Normally, here's my transformations conversation. Normally, when I plug in 0, I have, for a cosine curve, I have a max right here. Yay. But this one, you know, from the transformations perspective, has been reflected over the sinusoidal axis. So we're down here, actually, is what I think. Okay. Now comes the time for a little bit harder discussions and decisions. I've already kind of implicitly, without even telling you, scaled the y-axis in this way. And I think everyone's okay with that. No one is thrown off by that, even a little bit. The hard part is often comes in scaling the x-axis, right? We have to like think harder about the x-axis. We haven't yet said anything about the period, and there's something else I need you to notice, and that's this little degree mark here, okay? So we'd like to indicate by doing that we'd like to scale our x-axis. We'd like to think about our independent variables as being things measured in degrees. Okay, so with that in mind, what's the normal period in terms of degrees? Yeah, 360 degrees. So it's what's the period here though? It's 3 times that, isn't it? 1080, yes. If you're like into snowboarding or skateboarding, then like you're familiar with these like multiples of 360 maybe. I'm not as much, but 1080 is the period, right? I don't know, when you're, don't people do 1080s on snowboards and stuff? They go on the half pipe, you know, like if your name is Sean White or something. Isn't it possible? I thought, okay. All right. It's not a very common thing. All right. So I need to put 1080 on here somewhere. The other thing I need is like to divide this into 4 pieces, because I know that my beginning of the road is at 0 and the end of my road will be at 1080. That's convenient. 0 plus 1080 is 1080. And then I want to divide that into 4 pieces to decide where the maxes and mins and where the sinusoidal axis crossings are. Okay. So what is 1080 divided by 4? Well, what is it divided by 2? That's easy. 540. And then divided by 2 again is 270. So we're going to have markings. I'd love to put a marking on my road for 270 and 540, and 270 more than that is something. I don't know. So 810. Yeah. So let's see here. 1, 2, 3, 4. So we could just make 1080 here if we want, or I don't know, whatever. I'll just, for variety is the spice of life. I'll put 1080 here and 540 here. The point is, I'd really like to have those 4 markings on my picture. And if you don't see why yet, you will in a second when we start drawing it. So the start of our road on this particular one is not very interesting. It's just here. We already marked it. And then the end of our road is 1080 later, 1080 degrees later. We could go over on this side too if we like. Halfway through 540, we're going to have our peak. And any of these values you're welcome to actually plug in and check. At 270, we've got this value, and at 810 here, you see how I'm not even plugging them in. I'm just using the symmetry argument. Okay. And then I've got 1 full period ready to go right now.
That's a pretty graph.
Thank you. All right. And then if you want more, you can get more. Okay. So do you want to say anything more about that process? I think we kind of followed the process step by step, actually, even though if I didn't give you the process, you probably still follow it in the same order I just did. Okay, so not too bad yet. We haven't included a phase shift at all. That makes things a little trickier. So we'll do one of those here soon. A couple of them soon. Any comments you want to make? Are you getting good at drawing nice sine curves in your life? You should. I mean, that's part of what it means to appear smart, right? Is to like look smart, right? You want to be able to draw that like as if you know what you're talking about. Let's include a phase shift here on this next one. Okay. So we've got a couple things going on. I think this is the first one we've done with a phase shift up in front of you. It's actually not an omega. It's a phi or a e. You don't like it. All right, I'll do this part for you. Here it is. Y equals 0 is still the sinusoidal axis or the equilibrium point. 0.5. Let's call this 0.5. I don't know, just for fun. And we'll call this negative 0.5. Okay, and I've set you up for success now. There you go. Well, no, actually that was the easy part, right? Did you figure out the period yet? Have you thought about what's the base shift? We call it that. I'm just going to go down. Where's the start of your road? Right, 2. 2? Okay. How long is your road? Where's that going to be? Mark it off into 4. So.
4. Oh. Yeah, that is a long one. I mean, it's not that long. 4.
What's the period? What's the phase shift? 2 to the right. Okay. So I'd like to have it labeled in terms of what's a fourth of 2? Well, that'd be half, right? So I'd like to maybe make my grid lines on the x-axis marked in units of a half, maybe. So let's do that. That's not the end of the story, but we'll do that. 0.5, 1, 1.5, 2, 3, 4, 5. Choosing a scale is non-trivial. Okay. All right, and now I'm ready to plot a point here.
Generally, we only have to plot one period.
I mean, we can do 2 periods here just for fun. So 2, yeah. So the start of our road this time will be at 2. Right? There's the start of my road is at x equals 2. One thing you could do is actually plug 2 in, or you could think about transformations. This is sine, so you know where sine begins normally. It begins right on the sinusoidal axis. So I think that we have the point 2, 0. But of course, if you plug it in, it only takes a second to check that in fact we're right, using the algebra too. Good. The period we already advertised is 2 units, so here at 4, we're there again. This is a sine curve, so it's going to look like this, right? Let's be precise. Halfway in between, we've got another intercept. Halfway in between those, we get max and min. Beautiful. And we'll do 2 periods of this just because, no, we'll do 3 just because we love it so much. Yeah, we do. Okay. Are you ready? This is the fun part. All right, and then I hear you say, well, that's interesting. Because that looks a lot like, well, maybe you don't notice anything. I don't know.
Oh, I know. It looks like there's no phase shift.
It looks like there's, what did you say, Teo?
It looks like there's no phase shift because
like,
essentially if you imagine the sine curve as infinite, it would make no difference whether there was.
Yeah, it is infinite. You don't have to imagine it to be. It is. No, you're right. I know. So you conjecture that you could also maybe write this. If like someone showed you this picture, forget the equation for a second. If you covered this up and someone just showed you this picture, you might say, oh, that's the graph of what?
Blah, 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 blah.
Sine pi.
Right? Do you agree with Teo that actually if you saw this graph, you might be like, oh, that's the graph of this. And we're like, no, it's the graph of this. And the answer is, of course, that it turned out to be the same. So we're already like starting to see that
So
You're
would
like,
it only be different if you had a phase shift of like a decimal point, like 2.5 or something?
yeah, I mean, we're going to make the phase shifts interesting here sometimes, but we want to start thinking about this.
The phase shift, like, is it
Yeah, what would happen if we had said -4?
it'd be the same?
It'd also be the same. A multiple of the period? Okay, yeah.
Like a decimal or something.
So I want you to start.
Wait, if this period would work.
Hey, thanks, guys. I want you to start thinking about. That and having a conversation around that idea. Can you? I mean, because you're right to do this, right? Like, what if I shift this by 2, or what if I shift this by 4, or whatever? And Eric, I don't think everyone else heard you. If you shift by some multiple of the period, then you have done nothing, right? Yeah, exactly. There's
So if
more to
you-
say there, but go ahead.
It's also phase shift, like this particular 1 or 3. Could you just replace sine with cosine and like, get the exact same?
Close. Yeah. So yeah, what happens if you shift half a period? Can you re-express it in terms of something nice? What if you shift a quarter of a period? Can you re-express it in terms of something else nice? And the answer is yes to all those questions, and I want you to like start thinking about that. Yeah, absolutely. So in this one in particular, it's like super nice. The period and the phase shift happen to be the same, and you just saw what happens. All right, here's another one for you. Go.
Oh no.
Be studious and do this. Go.
Alright, that was really
Pretend for a second. Just right.
I feel like that's just so
Do this. It's not mean. It's just another example. Do it. It's good for you. I'm not trying to throw anything crazy at you.
Although you like.
No, I promise I'm not. You just need more practice. That's all.
Oh, down 2.
Make sure there's enough psychological space in this room for people to think. Quiet down just a little bit. Yeah, there we go. That's what I meant to say. Nope, I don't want to do that.
Oh shoot, it goes left.
The period is not
Wait, but it's down 2, but it's really up 2.
Already done?
Wait, why do I keep doing this?
the period because 2 pi divided by 1 divided by 3 is 2 over 3. Because that's the coefficient of t. Oh. I must provide this immediate watch Alex. Thank you for shooting me. Because the phase shift. Yeah, no. The phase shift is by multiple pi. But the period is not multiple pi, so that makes the x.
Oh shoot, I messed up.
Oh, I see. All I'm doing this comment, I don't want to get all this. I know.
Yeah, appreciate
I messed up. I did a case for the phase shift and the thing. No, I mean the
So easy to
It really doesn't have to be that tiny.
because that's high. Well, that's what
You did it going that way.
Yeah.
Oh, that just makes it so easier. Yeah, I need more space.
Look at short. I was assuming that I'm trying to find like an equation for normal. This graph was wrong.
Okay, but it's 8/3 of the interval in between.
all right. Oh.
Yeah.
All right, I know some of you are still. I know some of you are still working hard out there. Good job. Thanks for being so studious. Caden. All right, listen. I'm gonna poll some of you as we go through this. All right, are you ready? Caden, tell me anything, just one thing at all that would be helpful.
The amplitude is 1.
Okay, good.
Thank you, David.
You didn't offer much, but you're off the hook. Okay. Natalie, what else you got for me? Anything helpful that we haven't yet said, which is basically everything. Okay, sinusoidal axis is y equals -2. All right, I think with that information I can get started here, right? Y equals -2, and we're going up 1 and down 1 from there. All right, you guys have both helped us out tremendously. Thank you. You're welcome. Lucia, tell us something else we don't know yet. The period is 2/3. Do y'all agree?
Yes.
Emily, give me something else. Thank you. Thank you for that, Lucia. Give me something else. The phase shift is pi to the left. Sorry, Emily, I like you, but that's not completely. But that's not completely right. Okay. Did you want to hear that again? All right. Help us out here, because that is the tricky part. Matt's excited about this, I can tell. Okay, but explain. Explain, Matt. Explain.
So we would have to isolate the 3.
Listen, you.
So we would be like parentheses.
Okay, I'm with you.
In order to get pi as the other number, we would have to multiply by 1/3.
Yeah, so what is pi divided by 3 pi? Because that's what we're doing when we factor something out. Factoring out is also known as dividing, okay? So what is pi divided by 3 pi? It's 1/3, yeah. So now, Emily, I think you actually said 1/3, didn't you? That's what you actually said, wasn't it? 1/3? Yeah, that's right, okay. And for those who think this is going to be messy, actually, it's actually not that messy, right? In the end, okay? So give me a decent scale if you're ready. Maddie, do you have a decent scale for me that I can apply to the x-axis? I've already kind of set my y-axis, right?
5/3. Or, no, 6.
Oh, I did mine.
No problem, Matt.
To the left. No, this is.
All right, so 6. What motivates you saying that? Can you explain? Listen, guys, because this is important. I think this is like one of the harder things to think about. Is like, what's an appropriate scale that's gonna like work really well, set me up for success for the x-axis?
Because the phase shift is a multiple 1/6, and the quarters each, the smallest value is 1/6.
Yeah, so 2/3 is the period. The start of our road is at 1/3, and the end of our road will be at 1/3 plus 2/3, which is 1. And we need to divide that section up into 4 pieces, right? So what is 2/3 divided by 4? The answer is what Maddie said. 1/6. All right, so I think 1/6 is a splendid unit for the axis here. What do you think? I think it's a great idea. All right, and then I'll do the rest. You guys have helped me out tremendously. Here we go. Are you ready? Shh. Please stay with me, guys. Okay, bye. Shh. All right. So our start of our road is at -1/3 then. -1/3. So -1/3 comma what? Please stay with me. -1/3 comma what? Well, it's a cosine curve. So normally I'd be like, well, right here. But there's a reflection over the sinusoidal axis. So I think I'm going to say right there, okay? Do you agree? And remember that you can do a little reality check on me by actually plugging in -1/3 and seeing what you get, right? Do you agree that you get -3? Try it. Okay, the next place of interest to me is 2/3 of a unit later. Let's see, where would that be? 2/3 would be here, right? If we set up our scale and have these grid lines every 4, then that's nice. All right, there we go. And then halfway in between, we get a max. Oops, there. I know. All right, here we go. And again, I hear someone say, well, that is interesting. That looks a lot like... yeah, it looks like maybe we could have written this way. Do you believe that? Oh, excuse me. Right? Right now that seems to be true, doesn't it? Looks like just like a normal cosine curve with no phase shift. Interesting. Okay.
Why is that?
Yeah, I mean, what was 1/3? The phase shift in relationship to the period. It turns out to be exactly a phase shift of half a period, doesn't it? So that's interesting. Okay. And we want to kind of formalize our notions about this right now on this slide if we can in the last couple minutes. The thing that we've kind of been hinting at, even on day 1, yesterday when we were looking at the sine cosine curve next to each other, I think a couple of you observed and you said, hey, can't cosine be expressed in terms of sine or vice versa? Can't we just think of one in terms of the other as just a phase shift of the other? And the answer is yeah. Absolutely. In fact, cosine can be considered a phase shift of itself, right, too. I mean, we have lots of things we can do. What happens when we shift a sinusoid 1 full period? Well, nothing, right? Or what about any multiple of that period, like Eric was talking about earlier? The answer is nothing. What about half a period? What happens? What about a quarter of a period? Does something interesting happen? And that is, in fact, what's happening here. So think with me right now about the graph of sine of x plus pi over 2, for example. That's the graph of sine of x, normal graph of sine of x, shifted how much in what direction?
Left.
Yeah, left by a quarter period or by 90 degrees to the left, okay? So normally the sine curve looks like this. And right there, that maximum that I just drew is normally at what? X equals pi over 2. And so if we move it left, pi over 2 units, then does it make sense that we get a picture of cosine? I think that's just a visual argument, but I think that's pretty convincing. Likewise, can you graph cosine of x minus pi over 2 with me? What would that look like? Normally, cosine looks like this, right? There's normal cosine. But this is going to be a what? A translation to the left? No, to the right by pi over 2. So let me ask you, what is that point right there on cosine?
Please pardon the interruption for one afternoon announcement.
Yeah, does it make sense that if we
Tomorrow
shift that
before
to the
school
right,
is the
we
final
get
day
Sine?
of the book drive for Kenya. Books will be collected in front of the media center beginning at 7:10 in the morning. As of today, the counts are: sophomores are in 4th place with 103 books. Freshmen are in 3rd place with 357 books. Juniors are in 2nd place with 432 books. And seniors are in 1st place with 479 books. Good job.
All right. The bell is about to ring, but I think we should be able to graph these. I think we're able to graph these 3 equations and maybe think just visually about how we could express them in terms of just sine, right? So I did the first one for you real quick. Your homework will ask you to do a couple more tonight. Homework 2, after tonight you're going to be like an expert at graphing sines and cosines. That's my big goal for you.